Hi everyone, and welcome to part 2 of the Absio Python 3 SDK demo. In this part we're going to be talking about the Absio Integrated Encryption Scheme, or AIES. In this part we're going to be taking many of those low-level crypto primitives from the first section, specifically ECDSA, ECDH, and AES-256, and combining them into what we're calling the Absio Integrated Encryption Scheme, and allowing for very easy creation of one-way secure messages or key exchange. And let's go ahead and begin. So we start by creating key rings for both a sender and a recipient party. And we're going to do that by utilizing the key file function. We're going to provide key pairs for both signing and derivation. And this key file also requires a user ID, so we're just going to populate that with a UUID value. Now, in this demo, we've created both private and public key pairs. Now, that's just to make this demo easier. In real life, you would only be having the public keys for your recipient key file. You would not be in possession of their private keys. And from those key files, we would then create a key ring for both the sender and the recipient. So let's go ahead and begin and do that. As I just mentioned, we would only have the public keys for the recipient. This demo is just keeping it simple. So now that we have our key rings for both the sender and the recipient, we need to take a very secure message for your eyes only and create something that the recipient will then be able to decrypt using the public keys of the sender. So we can do this by calling absio.crypto.ies.encrypt, provide that very secure message as the data payload, take the sender's keys, which is us, and this should have both the private and public, and the recipient keys, which would only have the public. Run that through and we get some more random looking gibberish. Now, this doesn't mean anything to us, but from the recipient's standpoint, after it's been transmitted to them, the recipient can call absio.crypto.ies.decrypt, take that secure blob thing, provide their keys as the recipient, of which they have the private portion, and the sender keys, for which they only have the public portion from their perspective. Once they pass that through absio.crypto.ies.decrypt, we can now assert that the recovered data that they've decrypted matches our original data. And let's go ahead and do that. We can see that we have the very secure message for your eyes only. So now under the hood, what this has done is this has utilized ECDSA to take these signing keys and validate message authenticity, as well as ECDH to generate a shared secret, which is then used for creation of an AES-256 key, which is responsible for actually doing the AES-256 encryption and decryption. So you can see how we've taken many of those low-level primitives and combined them into something that is then very easy to transmit one-way type secure messages between parties. So that's it for the Absio Integrated Encryption Scheme. Stay tuned for part 3 when we talk about the full Absio ecosystem. Thanks.